Hey guys, good afternoon, good morning. We're going to start with graphing. We already saw some of this in our Desmos activity, but now here's the actual notes of how to line up the slope and the intercept with the graph.
During this segment, we'll look at equations of lines and we'll look at two important forms of lines. One we've already looked at before, that being the slope-intercept form. The other is a new form we'll look at in a moment, that is the point-slope form. First, let's review the slope-intercept form. Remember, when a linear equation in two variables is written in slope-intercept form, it is y equals mx plus b, where m is the slope, 0, comma b is the y-intercept of the line. Let's graph this linear equation in two variables, but let's use the slope-intercept form to graph. In other words, this is y is equal to negative 5x plus 0. Now, what does that tell us? I've written it in the slope-intercept form, so we know the slope is negative 5, but we also know the y-intercept is what? The y-intercept is 0, comma b, 0, comma 0.
0, comma 0.
So notice we have, from this slope-intercept form, we have a point of the graph. We also have the slope of the graph. Can we then use that to graph the line? The answer is yes. We can start with the y-intercept. Also just happens to be the x-intercept, so we can start with this point. And now let's look for a moment at this slope of negative 5. Do you agree I can write that as negative 5 over 1? If you do, then remember slope is rise over run, and I can use this fact to find a second point of the line. I can take this one point of the line, rise negative 5, run 1, and then wherever I land, mark a second point. So I start here, I will rise negative 5, so in essence I will move downward 5 units, and then I'll run 1 unit, which means from here I'll move 1 unit to the right. Once I do both of these movements, I draw a second point. It is a second point on the graph of my linear equation. So let's now graph the line through these 2 points. And it is the graph of y is equal to negative 5x. All right, so here it is. And there's the graph. Now, by the way, you may be wondering, well, what if I didn't write it as negative 5 over 1? In other words, you could have also thought of the slope as, say, 5 over negative 1. That's also negative 5. You could have done that and you would still be okay. You would start at this point. How would you move? This is rise over run, so you would rise 5, run negative 1. So rise 5, 1, 2, 3, 4, 5, run negative 1. You would end up at a different point, but still a point on the same line. So there's how we can use the slope-intercept form to graph a linear equation in two variables. Let's do this again. We are graphing. We're just using another method for graphing. We're graphing by the slope-intercept form. So let's suppose we graph this equation. 4x minus 7y is equal to negative 14. 4x minus 7y equals negative 14. One way to graph is, of course, to come up with 3 ordered pair solutions, graph them, and so on. But another way is to write this in slope-intercept form. So let's do that. Writing in slope-intercept form means solving this equation for y. So if I subtract 4x from both sides, I'll have negative 4x minus 14. I'll finish solving for y by dividing through by negative 7. I'll divide each term by negative 7. And then I'll have y equals, this is 4 over 7x, and then that's plus 2. Yes, that's correct. So what is the slope? The slope is 4 over 7. And what is a point of this graph? This is the y-intercept, 0, 2. So I do have this point, 0, 2. Let's use those two facts and graph the line. Here we have 0, 2. Now I will rise 4 units and run 7 units. Rise 4 units, run 7 units. So rising 4, 1, 2, 3, 4. And now let's run. Let me remove the word graph. And let's run 7 units. 1, 2, 3, 4, 5, 6. And then I can place one more tick mark here. So there is 7. So here is my y-intercept. From there, I rise 4, run 7. There is another point on the graph. And I can use that now, and I can graph my linear equation. And here it is. Let me be very
with the ruler and
careful
everything?
here and make sure, let's see. There we go. There we go. You can extend it, but there is the graph of this equation. 4x minus 7y is equal to negative 14.
Okay. Let me see if I can pause this.